Hi, this class we are going to talk something about problems in electrostatic potential and capacitance. Basic formulas for capacitors connected in series, capacitors connected in parallel, energy stored in capacitors, all these things we have studied. Now, related to that, we are going to see the problems. Okay, one by one. First problem. Two charges 5 into 10 power minus 8 coulomb and minus 3 into 10 power minus 8 coulomb are located 16 centimeter apart. At what point on the line joining the two charges is the electric potential zero? Take the potential to infinity to be zero. Two charges 5 into 10 power minus 8 minus 3 into 10 power minus 8. A and B 5 into 10 power minus 8 minus 3 into 10 power minus 8 coulomb. At this point O, RP, whatever it is, you can take. This is X. These two distances 16 centimeter. So that should be 0.16 meter. So remaining should be 0.16 minus X. Potentially 0 at the point P. What is the distance? You have to calculate. Basic formula, potential V1 at this point V2, V1 plus V2 is 0 at the point P. That is the concept. So formula Q1 by 4 pi F, this should be Q1, this should be Q2. Q1 by 4 pi epsilon naught, this distance X, plus Q2 by 4 pi epsilon naught, the remaining distance 0.16 minus X. Simplify this. 1 by 4 pi epsilon naught you can take common. Q1 by X plus Q2 by 0.16 minus X is equal to 0. This term cannot be 0. So I can write Q1 by X is equal to minus Q2 by 0.16 minus X. Q1 here is 5 into 10 power minus 8. Here minus Q2. So minus of minus plus 3 into 10 power minus 8 by 0.16 minus X. 10 power minus 8 cancel. 0.16 into 8 is 0.8 minus 5x is equal to 3x. So 8x is equal to 0.8, x is equal to 10 centimeter. So at a distance of 10 centimeter from Q1 charge, that is 5 into 10 power minus 8 coulomb, the potential is 0. Another possibility is also there. That is, on the same line, other side of minus Q charge, that is Q2 charge, other side. Here, if you keep the potential 0, what is happening? That also we can calculate. Same concept. A, B, here is the point. Minus 5 into 10 power minus 8 coulomb, minus 3 into 10 power minus 8 coulomb. The distance here is 0.16 meter. The total distance, let us assume as x, where the potential is 0. So remaining should be x minus 0.16. Previously, we have written 0.16 minus x. Now it is x minus 0.16. V1 plus V2 is equal to 0. Same concept. That is 1 by 4 pi epsilon naught, you can take common. Q1 by 0.16. No, no. At this point only. Q1 by x minus Q2 plus Q2 by x minus 0.16 is equal to 0. So I can write Q1 by x is equal to minus Q2 by x minus 0.16. 5 into 10 power minus 8 by x minus of minus plus 3 into 10 power minus 8 by x minus 0.16. Okay. So cancel 5x minus 0.8 is equal to 3x. 8x is equal to 0.8. No, 5 minus 2x is equal to 0.8. X is equal to 0.8 by 2, 80 by 8 by 20. That is 40 centimeters. 0.4 meter. 0.4 meter or 40 centimeter. 40 centimeter from minus q charge on the other side, or 10 centimeter from plus q in between. Both are correct. At this point, the potential is 0. That is the question. Okay, fine. Second problem. A regular hexagon of size 10 centimeter has a charge of 5 microcoulomb at each of its vertices. Calculate the potential at the center of the hexagon. At the center, here we have to calculate 10 centimeter. Charge 5 microcoulomb everywhere on the vertices. So each vertices component, each vertices contribution is there toward the center. 5 microcoulomb, each one has its own contribution. So the potential is basic formula Q by 4 pi epsilon naught R. But all the 6 vertices has got a contribution. So we have to multiply by 6. That's all. So 1 by 4 pi epsilon naught is 9 into 10 power 9. Q value 5 into 10 power minus 6 divided by R, 10 centimeter, 0.1 meter. Of course, we have to multiply by 6. Calculate the potential. It is 2.7 into 10 power 6 volt. State succession. This concept into 6 you have to multiply that concept alone, you have to keep it in your mind. That's all. Remaining same. Basic formula for potential. Okay. Next. Third problem. A parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. What will be the capacitance if the distance between the plate is reduced by half? Space between them is filled with a capacitance substance of dielectric constant epsilon r is equal to 6. Parallel plate capacitor in air. Basic formula epsilon naught A by D. I think that value given. What is the value? 8 picofarad. Picofarad means 10 power minus 12 farad. Okay. Now, C medium. Epsilon naught, epsilon R A by the distance is changed here. Distance is reduced to half. So it cannot be D, it should be D dash. Moreover, a substance is introduced. So we have to multiply by epsilon R. So I can write epsilon naught A by D dash is D by 2 into epsilon R. So epsilon naught A by D is C air. This 2 will go to numerator, 2 epsilon R. So C medium is C air, that is 8 picofarad into 2 epsilon R value. Dielectric constant is 6. 8, 12 8s are 96. 96 picofarad. Correct? 96 picofarad. Fourth problem. 3 capacitors, each of capacitance 9 picofarad are connected in series. What is the total capacitance of the combination? What is the potential difference across each capacitor when the combination is connected to 120 volt supply? Three capacitors connected to 120 volts. Value of each capacitance will be 9 picofarad. C. 1 by Cs is 1 by C1 plus 1 by C2 plus 1 by C3. That is 3 by C. Cs is equal to C by 3. So I can write Cs is equal to 9 picofarad by 3. 3 picofarad. So resultant capacitance is 3 picofarad. This is first part. Second part, they are asking what is the potential across each capacitance. In the case of parallel combination, potential is constant. Series combination, the potential is different. But all the three capacitors are same value, C. So, total value of this is 120. That is equally shared among its capacitors. For three capacitors, potential difference is 120 volt. Therefore, potential difference across each is equal to 40. 40. Otherwise, you have to calculate Q is equal to CV. Charge is same in series connection. V is equal to Q by C. Q by C1, Q by C2, Q by C3, you have to calculate. That's all. In this case, all capacitance are same, so we are getting the same value. Otherwise, V is equal to Q by C formula, we have to substitute. Q is constant for all. So, fifth problem. Three capacitors, 2 picofarad, 3 picofarad, and 4 picofarad are connected in parallel. What is the total capacitance of the combination? Determine the charge if the potential is 100 volts. Cp is equal to C1 plus C2 plus C3. 2 picofarad, 3 picofarad, 4 picofarad. Totally 9 picofarad. This is first part. Straight problem. Second one, what is the charge? In the case of parallel combination, potential is constant, but charge is different. So Q1 is equal to C1B. That is 2 into 10 power minus 9 into 100. 2 into 10 power minus 7 coulomb. First part. Second, Q2 is equal to C2B. 3 picofarad into 100. Pico. 10 power minus 12. So minus 10 coulomb here. Next, 3 into 10 power minus 10 coulomb. Third one, C3V. 4 into 10 power minus 12 into 100. That is 4 into 10 power minus 10. So in series combination, charge is same. In parallel combination, potential is same. Basic one. Next, a parallel plate capacitor with air between the plates. Each plate has an area 6 into 10 power minus 3 meter square. Distance between the plate is 3 millimeter. Calculate the capacitance of the capacitor if the capacitor is connected to 100 volt supply. What is the charge on each capacitor? Question number 6. C air, C naught you can put or CA you can put, no problem. Epsilon naught A by D. Epsilon naught 8.85 10 power minus 12. Area 6 into 10 power minus 3 divided by distance separated by 3 millimeter. 3 into 10 power minus 3. 2 times cancel 8.85 into 2. 17.6. Nearly 18 into 10 power minus 12 farad or 18 picofarad. Next, charge is asked. Q is equal to CV. 18 into 10 power minus 12 into potential given as 100 volts supply. So I can write Q is equal to 18 into 10 power minus 10 coulomb. So it's correct. Capacitor, parallel plate capacitor with air. With the dielectric means epsilon naught, epsilon R, A by D. That is fully dielectric. Partially dielectric also we will see in the future problems. Seventh problem. Explain what would happen if in the capacitor given, that is 18 picofarad, 3 millimeter thick mica sheet of dielectric constant 6 were introduced between the plates. What will happen to the voltage supply remains constant after the supply is removed. First thing, when the voltage supply remains constant, what will happen is a question. Basic formula C R or C naught epsilon naught A by D 8.85 10 power minus 12 area same in the previous problem 6 into 10 power minus 3 distance or thickness of the plate 3 millimeter 3 into 10 power minus 3 we have simplified CR 18 picofarad C medium epsilon R into CR epsilon R epsilon naught A by D. Epsilon naught A by D is CR. So multiply by dielectric constant straight away. What is dielectric constant given in the problem? 6 into 18 picofarad. Calculate 18 6 or 96 102 108 picofarad. Now the question is what while the voltage supply remains connected, what will happen to the capacitance? If the dielectric inserted between the plate, what would happen if the capacitor is given when voltage supply remains connected after the supply is disconnected? When voltage supply remains constant, when voltage supply, that is first part, when supply remains connected, when supply remains connected, V is constant. Therefore, Q is equal to C medium into V. What is C medium? 108 into 10 power minus 12. This is 100 volt. 108 into 10 power minus 10 coulomb. One not eight into 10 power minus 10 coulomb. When supply is disconnected, Q is constant. Charge is constant. You are pumping the motor. You are pumping the water through the motor. When motor is on, water is continuously coming to the overhead tank. When you switch off the motor, whatever water stored in the tank is fixed. That's called charge here. The charge is fixed. Okay. What will happen? potential difference V is V naught or Vm is equal to V by epsilon R. Potential difference is reduced because the system, what has happened here, you have connected a dielectric constant. When dielectric constant is introduced between the plates of the capacitor and battery supply is disconnected, then the voltage across them is reduced. What factor it is reduced means by the dielectric constant. What is actual voltage? 100. Dielectric constant is 16.66 volt. Okay. So two cases we have studied. One case is charge battery supply permanently connected means charge you have to calculate. Battery supply disconnected means potential is constant and then you are calculating. Q is constant, here V is constant. Excellent problem. Seventh one. Eighth problem. How much work is required to carry 6 microcoulomb charge from negative to the positive terminal of a 9-volt battery? Negative to positive, you are carrying a charge. How much energy is required to carry them? Simple question. Basic formula for work done or energy. In the case of capacitor, work done is charge into potential. W is equal to Q into V. Straight formula. Work done in moving a unit charge from infinity to any point inside the electric field. That is called electric potential definition. Here we are not moving unit charge, here we are moving Q charge. So multiply by Q. So that is called the work done. So W is equal to, what is the charge given? 6 microcoulomb, 9 volts, 54 into 10 power minus 6 joules. Straight problem. Correct? Ninth one. The equivalent capacity of two capacitors in series is 3 microfarad. CS is equal to 3 microfarad. In parallel, it is 16 microfarad. Calculate C1 and C2. That is a question. Cp is equal to C1 plus C2. What is that value? 16. 1 by Cs is equal to 1 by C1 plus 1 by C2. C1 plus C2 by C1 C2. So Cs is equal to C1 C2 by C1 plus C2. The series capacitance value is given. What is the value? 3 microfarad. C1 C2 by C1 plus C2 is 16. This is 3. So C1 C2 is equal to 48 into 10 power minus 12. Microfarad. Micro means 10 power minus 6. There also minus 6. So minus 12. C1 plus C2 is 16 microfarad. So product of two numbers is 48. Sum of two number is 16. 12 and 4. 12 into 4 is 48. 12 plus 4 is 16. So C1 12 microfarad. C2 4 microfarad. 10th one, 4 capacitors are connected in a circuit as shown. Find the capacitance between P and Q. Between P and Q, you have to calculate. What are the values? 2 to 12 to 2 microfarad, 2 microfarad, 12 microfarad, 2 microfarad. These two are in parallel. Equivalent circuit first we will draw. These two are in parallel. Connected to another capacitor in series. Another capacitance in parallel. So P and Q is here. 2 microfarad, 2 microfarad, 12 microfarad, 2 microfarad. C1, C2, C3, C4. From the diagram, it is very clear that these two capacitors are in parallel. So we can write Cp is equal to C1 plus C2, 2 plus 2, 4 microfarad. This 4 microfarad and 12 microfarad are in series. Now, Cp and C3 are in series. So what will happen? Cp and C3. For 1 by Cs is equal to 1 by Cp plus 1 by C3. 1 by 4 plus 1 by 12. 12 LCM, 3 plus 1. 4 by 12. So Cs is equal to 12 by 4. 3 microfarad. This 3 microfarad and 2 microfarad are in parallel. Therefore, what will happen? Cp is equal to Cs plus C4. Cs is 3. C4 is 2. So the total value will be 5 microfarad. Cp is equal to Cs plus C4. Cs is 3. C4 is 2. So totally 5 microfarad value. If it is other than the normal, try to write or try to draw equivalent circuit for that capacitors. Straight away it is connected in series parallel combination means you can write. But question like this means equivalent circuit you have to draw, from that you can calculate. 11th one. In the circuit shown as in the figure, calculate the potential difference across 4.5 microfarad capacitor. Question: one capacitor, another two capacitors connected in parallel, entire combination connected to a supply voltage that should be 12 volts. This is C1, 4.5 microfarad. This is C2, this is C3. What are the values given? 3 and 6. 3 microfarad, 6 microfarad. 3 and 6 microfarad you have to calculate. These two are in parallel. So I can write Cp is equal to C2 plus C3. Value 3 plus 6, 9 picofarad. This 9 picofarad and this 4.5 microfarad, sorry, this is microfarad are in series now. So you can write Cp and C1 are in series. So 1 by Cs is equal to 1 by Cp plus 1 by C1. Cp is 9. C1 is 4.5. 9 LCM 1 plus 2. 3 by 9. So Cs is 9 by 3. 3 microfarad. So you have connected the capacitors here. What is the question given? Find the potential difference across 4.5 microfarad. Potential difference you have to calculate. What is the basic formula for potential difference? First you have to calculate the charge. Q is equal to Cs into V. Cs is 3 into 10 power minus 6. V is 12 volts. 36 into 10 power minus 6 coulomb. Therefore, potential difference across this. Therefore, potential difference across this V1 is equal to Q by C1. Q is 36 into 10 power minus 6 by C1 is 4.5 10 power minus 6. Cancel 8 4. So 8 volt. State substitution 8 volt. Okay. 12th. The plates in a parallel plate capacitor are separated by a distance d with air as the medium between the plates. In order to increase the capacity by 66%, a dielectric slab of dielectric constant phi is introduced between the plates. What is the thickness of the dielectric slab? Distance d for air medium. We have to increase the capacity by 66%. That is a constant. That's a constant, dielectric constant phi. Epsilon r phi. What is the thickness of the slab? They are asking. Introduce the thickness. Dielectric slab. Capacitance increases by, definitely capacitance increases because it is directly proportional. C air is epsilon naught A by D. C medium is epsilon naught epsilon r A by D. So C medium and epsilon r both are directly proportional. So if epsilon r is introduced, capacitance will increase only. Basic concept. What is the thickness of the slab is the question. Formula for air, C naught or C air, epsilon naught A by D. C medium, epsilon naught A by D minus T plus T by epsilon R. So Cm by Cr, you calculate. Or Cr by Cm, anything. This by this means these two get cancelled. This will go to numerator. D minus T plus T by epsilon R divided by D. Epsilon R value given as pi. So Cr D minus T plus T by phi by D. Cr by C meter. Question is Cr is 100 means it is increased by 66 percentage. So this is 166 percentage. Percentage get cancelled. D minus T plus T by 5. So T by 5 minus T. T minus 5T by 5. 4T by 5. 100D 166D minus 40 by 5. So 40 by 5 is equal to 166D minus 100D. That is 66D. So T is equal to 66 into 5 by 4 of calculate. So this 166 is multiplied here also. By 166 into 4. Calculate, it is half. 66 into 5 by 166 into 4. It is half almost. 49.9, 0.49 something you will get that. That is 0.5, 0.5. So the dielectric constant slab thickness is half of the distance between the two plates. Okay, fine. Next, 13th problem. Three capacitors C1, C2 and C3 are connected to 6-volt battery as shown. Find the charges on three capacitors. Battery C1, C2, C3. This battery value 6 volt. This is C2, this is C3, this is 6 volt. C1 value 10, C2 5, C3 5. 10 microfarad, 5 microfarad, 5 microfarad. Equivalent circuit we have to draw first. So battery, first capacitor, these two connected in parallel. C1, C2, C3. This is 6 volt. C2 and C3 connected in parallel. So what will happen? Cp is equal to 5 plus 5, 10 microfarad. C1, Cp are in series now. Therefore, 1 by Cs is equal to 1 by C1 plus 1 by Cp. So I can write 1 by Cs is equal to 1 by C1, 1 by 10 plus 1 by 10. 2 by 10, that is 1 by 5. Cs is equal to 5 microfarad. So the effective capacitance of the combination is 5 microfarad. Question is, what is the charge on each capacitor? Already we have discussed, in series connection, charge is same. In parallel connection, potential is same. These two are in series. Calculate the total charge. Therefore, Q is equal to CV. What is C? 5 microfarad. V is 6 volt. 30 microcoulomb. So 30 microcoulomb passes through C1, 30 microcoulomb passes through Cp. So charge across C1 is equal to 30 microcoulomb, and charge across Cp, charge passing through Cp, that is also 30 microcoulomb. You know very well, Cp is what? 5 plus 5, C2 and C3. So two capacitors connected in parallel, that is called Cp. Okay. So both are 5 microfarad. Capacitance is same. So the charge passing through it is also same. Otherwise, two charges will be different. Potential is constant. Since capacitance is also constant, charge is divided. Charge is divided here. Q is equal to Cv. Total charge is 30 microcoulomb. Therefore, charge is divided among C2 and C3. That is 15 microcoulomb each. Total 30 microcoulomb. Across C2 15, across C3 15. Or through C2, through C3, 15 plus 15, 30 microcoulomb. Okay. So these are the basic problems in electric potential, electrostatic potential and capacitance. So many problems we have. Combination of capacitors, correctly equivalent circuit you have to draw. And thumb rule, right hand rule, or basic concept here is, in parallel connection of the capacitor, potential difference is constant. In series connection of the capacitor, charge is constant. This concept we have to keep it in mind and apply according to the problem. Okay. Thank you. We'll continue.